Welcome back to the Structural Engineering Podcast. This week we're continuing our conversation at Louisiana Pacific with Scott Johnson. Scott spent quite a bit of time working as a structural engineer for a consulting firm before joining LP, and we get the chance to ask all about fire in wood design for structural engineers and beyond. This is a topic that I probably didn't know exactly where it fell for responsibility, but knowing the principles of fire design can go a long way in helping make a successful project. So listen in, and if you have any questions, send them our way or directly to Scott. Thanks, and enjoy.
Well, Zach, Max, first off, thank you for having me on the show. Scott Johnson with LP Building Solutions. My role is called the Construction Services Manager for the OSB business. It really doesn't say what I do, but I like to call it an easy button for customers, our sales staff. Been with the company about 7 years, a little over 7 years. Prior to that, I did consulting engineering for, 15 years, and then had a transition in life. I'm like, all right, what could I do now? And so I jumped into, left the engineering profession and went to sales. Transitioning to sales, it was like, you bring this engineering mindset of, you're a problem solver. So it kind of worked into the position that I have now where, I kind of have free reign to help people with our products, answer questions. I get to do testing. I do a lot of our fire testing, a lot of R&D, getting an idea. I have to go find somebody to help me pay for it and then set up the testing. Kind of that in a nutshell.
Well, thanks for joining us today. We're excited to talk to you about fire engineering. I think it's going to be a pretty cool topic, and one a lot of our listeners have asked us questions on. Where do structural engineers fit within that? And I think that's what we're excited to talk about today.
Yeah, it feels like a very complicated topic, and I really have no understanding of it. So I'm excited to learn a little bit of this. I'm going to start with a very broad question. Who is responsible for fire design? I think in my head, a lot of our typical details kind of lean to that, and steel design and concrete design, I feel like it's held in the typical details, but not something that I often have to think about. But as we're leaning towards more mass timber, we get questions about fire design. So I just really have no idea.
That's probably the $1 million question. Yeah. Probably what the easy answer is probably everybody is, architect and engineer. But, the architect, I think, has the life safety drawings, in their set, in their drawing set. And so probably they're the ones who are responsible for it, and probably more responsible defining what the criteria is for the fire resistant construction, and it's, how do you go about protecting the building? And I do think ultimately that's on the architect, but it's a collaborative effort. I review a lot of drawings, and there's 90% of them are miscoordinated on things,
yes.
That they leave out.
If the architect needs a resource, like, is there a category, an engineering category, or that does fire work?
Well, I think a lot of times, like kind of the world I play in, that it's deals with wood, because we're a wood company, we manufacture wood products. So, a lot of times for the architect, if we're talking wood frame, it's rated floors, rated walls, 1 hour, 2 hour walls, resistance from one side, resistance from both sides. How do you protect your rim? That's kind of stuff that there's resources for, but there's also holes in the industry on certain things.
Yeah. Do you see the responsibility moving in the future, or do you think it's where it's falling right now is sitting on everybody? That's probably where it should be, because everyone should be aware of the safety.
Yeah, I think when it comes to the wood part, I think it's a great opportunity for the engineer to show his value. Again, an architect, they may just pull these standard assemblies, kind of like how engineers use structural notes, standard details. They probably use standard assemblies. But it might be a way for them to value engineer something. Maybe they know of systems or, that might be beneficial to a project. They might be able to catch things that aren't coordinated between the two sets. Again, I always go back to the rim condition, because that's never coordinated. It rarely is, because a lot of times you need to maintain that fire resistance through that rim space. If you have an exterior wall, a lot of times you put a single rim down, but a single rim by itself doesn't have the fire resistance and still the ability to maintain load.
So where do we start? I'm assuming we start in the IBC, as we do with most of our structures, but with the IBC, where do we go from there?
Well, Zach, Max, I don't know if you guys know this, but I didn't realize there was a chapter 1 through 15 until I came to work for LP, unless, you probably get some random plan review comment like, please address, how you're satisfied in 5.62 of, So, kind of backing up a little bit. And this is stuff I don't know if a lot of structural engineers maybe know. And it wasn't something I really knew or paid much attention to it, but it kind of starts in chapter 6. So you look at the construction type. As you know, there's 1, 2, 3, 4, 5, or 4 is kind of the heavy timber. I think they've renamed it 5, but you always try to build the most efficient, right? So you're going to start with construction 5. Well, I don't satisfy the height requirement. I want to build a taller building. So maybe that kicks you into type 3, but maybe there's something like your square footage. So now you're in type 1 or type 2. And with, it's kind of inverse, but it's like starting with like type 1, that's, your structural elements are non-combustible, and they have a certain kind of rating to them. And then obviously as you work down, and then it kind of kicks you. And then there's another table 601 is kind of based on the construction type, and then there's a table 602, which is based on the occupancy and the construction type. And everybody interprets table 602 differently, but we won't dive into that. And then you go into chapter 7. And chapter 7, I think for structural engineers to read up on, kind of know that chapter is probably a good thing for them. Tells you the ways you can demonstrate fire resistance, via calculation, assemblies, chapter 16 of the NDS for wood construction. There's also some things in there that maybe you can help find value to your architects. Again, we're talking IBC stuff. So exterior walls, like greater than 10 feet from a property line, you only have to have the resistance on the interior face. So a lot of times, again, look through a lot of drawings, the architectural would show an assembly that has resistance from both sides, and maybe it doesn't need it, right? So you could shave layers of gypsum off your wall, so you can do a thinner wall assembly, which obviously less layers going up on the outside helps expedite the construction process.
Yeah. I have a real basic question. This is definitely going to be an example of I should read chapter 7, get my feet under me. But talk about building types. Is it specific enough that, if you drive by a commercial structure, a 2-story typical office building, you know exactly what fire type it is, or is it kind of a broader?
You probably have a good idea what the construction type is. Yeah. Like this building we're in, probably type 2. Okay. And then obviously, the 20-story buildings next to us, because we're in a 3-story office building, concrete. So it's probably type 2, maybe type 1. Yeah. And then, obviously the tall ones are type 1. Kind of like how I tell our salespeople, if they're trying to figure out, because we play in the world of type 3 and type 5, right? If it's 5 stories of wood frames, probably type 3.
Is the number more stringent as the number goes up, or
as the number, it's kind of opposite. It's less stringent as you go from 1 to 5.
Okay.
Yeah. So like type 3, kind of the general, in a nutshell, what it is the interior can be combustible. The exterior has to be non-combustible, or that exception for fire retardant treated wood. Yeah. Type 5 can be all combustible materials. And that's why I say it kind of goes back to, you kind of start at type 5 if you can, right? Because it offers the most flexibility. But like you said, it's wood frame, but we want to go 5 stories. All right, so now you're getting kicked into type 3, but I have to use fire retardant treated lumber and non-combustible exterior walls.
Probably back to me, I'm not knowing anything in this category, but is it related to, obviously, is the size of the building? Like you have a ballpark, like you said, a tall building is category 1 or something like that. Is it because it has its square footage is past some point, like you just get, it takes down what you can choose from?
Yeah, so I think, and I'm not a pro at this. I know enough to be dangerous. And I think it's chapter 5, which kind of defines, okay, for this building type, sprinklered, unsprinkled, this occupancy, here's how many floors you can go. Yeah. And then there's another table for the square footage you can go. And sometimes you can just stay with like type 5, and this is done pretty often, is you basically joint the building. So let's say your square footage exceeds what you have to do for type 5. Mm-hmm. So you joint the building. You put you basically break it into two individual buildings, but really it's one.
And so that when we see like fire doors,
Yeah,
maybe a break stuff.
Yeah, and that's essentially what they're doing. It's like, here's a building, here's a building. It looks like the same building, but it's different buildings. I know, and like in the seismic country, when you walk through those fire doors, you'll see like the throat, it's probably, 18 inches, but that's because of that seismic joint that they would have in there.
So they have to be like structurally totally independent buildings.
Mm-hmm. Well, except in seismic design category D and above, you're allowed to continue a diaphragm through.
Oh, interesting.
Yeah. So you can run your floor sheathing through minimum. I think you can only go up to 3/4 inch sheathing because I think they want to be able to, one can fall away. Obviously not pull the other one down.
Yeah. I'm guessing that's fire rated sheathing.
Nope.
Really?
Yeah.
Okay.
Again, everybody interprets stuff different all over the country, but I am not aware of any requirement in the code that says your floor sheathing has to be fire resistant.
Okay.
Because I was saying, like, going back to type 3, type 5, again, that's kind of the world of wood frame. Floors can be combustible materials. So, yeah, some jurisdictions might require like 4 feet around the rim or 4 feet around the perimeter that be fire treated sheathing. But I can't find that in the code. I
wonder if it leans that way because the floor is always covered. Like the drywall is exposed. You're getting directly to fire, but like the floor probably has tile on it or whatever. So
yeah, I think it's just I think some of it is just maybe people they're like, I don't know, we're just going to require that, And here's an interesting thing. When I say type 3A, type 3B, what do you know what the difference is?
No.
You know what? It took me a long time to figure that out. It goes back to table 601. A means your floor is rated. B means your floor is not rated.
Wow.
Or 3A is 1 out. You have to have a 1 hour floor system. 3B means your floor doesn't have to be protected. 5A, same thing. 1 hour floor. 5B, you don't have to rate the floor. Yeah, it's a little bit different when you're in type 1 and 2, but I'm like, how do I find the difference between 3A and 3B? And then I had it's not like spelled out. It's just, you have to like, the table tells you.
Yeah. So Scott, as structural engineers, why is this an important topic for us to talk about today?
Well, I think it's, first off, I wouldn't call it fire engineering per se. I'd say fire resistant construction, So I think this is a great opportunity for structural engineers to demonstrate value, right? Because here's a common answer I hear a lot from structural engineers. It's like, I don't do fire. I don't do fire. And it's like, fire is actually pretty easy. And it's a great way to show value and to take it on, and, like I was saying, learn chapter 7, go through chapter 16 in the NDS. It's like 3 pages, It's a pretty simple thing, and you'll be able to, I think by having that value, you could head off potential issues during construction. Oh, hey, it's type 3. Me as the engineer, my exterior walls, if we're using wood, it's like, oh, I got to put fire treated studs in there. Oh, I need to look at, what treatment they're going to use. What are the reductions associated with it? If I'm putting sheathing out there, what sheathing am I going to use? Again, there's probably might be some reductions associated with it, and then kind of going back to, hey, you may know of systems, the architect, might you have boilerplate assemblies they've been using. And when I say assemblies, I'm talking like UL assemblies or assemblies tested at ASTM E119. They might just be boilerplate they've been using for years. And again, that's where the engineer can go, hey, you know what? Here's another system you could potentially use, or here's a section in the code that says, hey, we don't need to have that resistance from the exterior side. So saying, hey, why don't we change this? Let's pull a layer of gypsum off the exterior wall. Or, this is a little convoluted, but like stair towers or elevator towers where they're exterior walls, right? Commonly, if it's type 5 and you're over like 4 stories, that core is a 2-hour system. But if it's 5A, part of that is part of the exterior wall, you only have to have a 1 hour. So a lot of times you'll go through drawings and the architect will be showing that portion of the tower is a 2-hour wall with let's say 2 layers of drywall. And then the the remaining wall is only a 1 hour that has one layer of gypsum. So now they have this jog in the building. So I think there's ways, I mean, you can really dive into the details, learn as much as you want to learn, but I think it's just offering that value to, head that off during construction.
Yeah.
The flip side of that, is that, if you catch on to something, it's like, okay, this is what we need to do, but it's more than what people are accustomed to doing. You might get pushback like, well, we didn't do this before. Why do we have to do this now? And then you're just over engineering it, it's like, you know what I'm saying? That dilemma, sometimes engineers, I think if they're doing the right thing, they're doing what they're supposed to do, and other people aren't doing it, they might get the perception that they're over engineering. So that's where it's the opportunity, to show your value,
Interesting. And actually on that, like, does fire code change at the same pace? Like, obviously we get a new IBC every few years. Are there updates to the fire code, or is it fairly consistent?
I think it's been fairly consistent. They might change like some of the, testing requirements. Mm-hmm. So, the IBC might reference, this ASTM test standard. So that ASTM standard may change a little bit, but it's still kind of being referenced in the building code.
Yeah, I think going back to what you said about, clients saying, hey, you guys are over-engineering this, I find it to be really important that we need to be educating the clients, right? That's usually why they say it, that we're over-engineering things, because they're ignorant to what has changed or why we need to change something. So I found, at least in my own career, that comes up quite a bit. Hey, this looks way different than what we did 10 years ago. Well, the building code has changed significantly in even just 10 years. So yeah,
it's the person that goes, I've been doing this for 30 years. Yeah. And you're like, man, people used to smoke when they were pregnant 30 years ago. I mean, people had rotary phones 30 years ago. Cars were carbureted 30 years ago. Anyway.
Okay. So yeah, kind of moving more into what you do on a day-to-day kind of basis. We want to talk about the type of testing you do for the products that you guys supply. When Max and I were looking into fire testing, we found a lot of different things. So ASTM E119, which we've discussed with others on another fire podcast we did. That was mostly towards steel when we discussed that. There's UL 263, NFPA 251. So, what are you most familiar with utilizing, and how does that procedure work, and what does that look like for you?
So going to, like, for the fire testing, and when we're talking, I'll say, again, kind of geared towards wood frame. There's basically two types of testing that are looked at. There's E119 /UL 263. UL 263 is basically UL's rewrote E119 kind of thing. A lot of times, a little segue on that. A lot of times people say, I need a UL assembly. Well, the assembly does not have to be a UL assembly, because UL is an agency that basically witnesses testing to a standard, then gives you a report. You can have assemblies from Intertek. ICCS has assemblies. UL obviously has assemblies. So the E119, in the wood frame world, is walls and floors. And then the other one is E84, or they might call it extended E84, and that's kind of the requirement noted in 2303.2, I think, of the IBC, which defines the criteria for fire retardant treated wood. So it's an E84 test, which is a 10-minute test, and then for the wood, you extend it to a 30-minute test, and that's a flame propagation test. That's basically how will flame propagate across the surface. It doesn't equate to fire endurance, which is like what E119 is. That's like a wall that's exposed, to the furnace when you test it for 1 hour, 2 hour, whatever it is. They're kind of night and day. And kind of my analogy I give people is, let's say you had a, condensed flame, or, maybe like on your stove at home, you have a propane oven top, right? Sheet metal, right? Flame propagation doesn't burn, right? So the flame won't propagate because it's basically a flame with a draft, and you're trying to push it along a surface, across a horizontal surface. So sheet metal, right? Flame won't propagate because it doesn't bust. Do the same thing with wood. The wood's with that draft is going to propagate down the wood. So wood has a poor flame spread performance compared to like sheet metal. So when we get to the fire endurance part, the E119, right? Same thing, but put your hand on it, right? if you have that sheet metal and you put your hand on it, the heat goes right through, right? And think of wood, right? You put wood on it, the it's going to insulate it a little bit. It might be burning really bad, but it's insulating. So sometimes people equate flame spread performance with fire endurance, and they're not necessarily apples to apples.
Again, this is kind of a silly question, but if you talk about a 1 hour rating, what does that mean while I'm thinking about this? Like, is that a temperature on the other side of the test? Like, what does the test actually look like?
Yeah. So that's a great question because, it's a great question. And I've seen behind the curtain because I do a lot of our E119 testing. 1 hour, if you get a 1 hour wall, 2 hour wall, it means it's been evaluated to a standard for 1 hour. Let's just say 1 hour. And it made it through that criteria for 1 hour.
Is that like it could still stand after 1 hour?
So what you do is basically it's a 10 foot by 10 foot mock-up, and it becomes one wall of a furnace. Or, and then they crank the heat up and it just shoots up, in minutes it's, about 1,200 degrees. And then it's kind of like the concrete strength, it kind of asymptotes out or limits out or whatever. So it gradually keeps climbing. So, it's around 2,000 degrees, so for about 45, say an hour test, for about 45 minutes, it's hovering around 2,000 degrees.
Yeah.
On the furnace side. And so if it's a loaded assembly, load bearing assembly, they compress the wall. They have hydraulic rams that apply an axial load to it. And then that's one part. It has to sustain the load for the entire test. And then the temperature can't rise on the opposite side, the unexposed side. So there's a temperature threshold. So like during these tests, you can go up, say it's an hour test, 30 minutes into the test, you put your hand on the unexposed wall, you don't even feel a thing. It's not until like the later stages that the wall you're starting to feel that heat coming through. So it's kind of like, it's pretty impressive. And then, whatever material is on the furnace side, it's all sacrificial, right? So eventually that breaches, the studs start burning, and if you pass a test, typically, this thing is bowed out, it's deflected 3 inches, just because it still has to sustain the load. And then if you sustain the load, flame doesn't come through, temperature doesn't rise, that's considered a pass test. Now there's a second part to it where it's a hose stream test. So the hose stream, basically what most people do is you'll do the full endurance, the 1 hour, and then for the hose stream, you run it for half the time. So you would do a 30-minute test. They pull it out of the furnace or pull it away from the furnace, and then they hit it with like essentially like what a fire hose is.
Yeah.
And I think for 1 hour, it's 1 minute, 2 hours, 2 minutes, and they have differing pressures that they use based on the time. And basically water can't come through the other side. So that kind of mimics to me, it seems like, okay, there's a fireman's hitting with the fire hose. That wall doesn't buckle under, doesn't collapse.
It's a weird specific one, but does it, when we look at fire, when we look at the load capacity, right, in a fire, is it a reduced amount that we're testing to? Because I know the codes and like what word am I trying to say?
Hey, I know.
Yeah.
This is something when an engineer will call me up and they'll read through our evaluation report and they're like, why is your load reduced?
Yes.
And it's like, it's not reduced. So for those taking notes, right? I said it's a 10 foot by 10 foot mock-up, right? So if you take a stud, 10 foot, on a 10 foot wall, you subtract out 3 plates, 2 double top plate and the bottom plate. That stud is 115.5 inches, right? Divide that by 3.5, because the depth of stud, your slenderness ratio is 33. So that's a 2x4. So a 2x4 wall, 10 foot tall, slenderness ratio of 33 is controlled by buckling, right? So when you look like in evaluation reports, right, you'll see like LRD of 33 and it will say like 387 PSI. And you're like, well, that's not very much. But that 387 or whatever it is based on the buckling capacity of a 2x4 stud with that slenderness ratio. So if you take and it's the same criteria. There's a table, I think it's 721.2, and I think it's footnote M or L. So that same requirement is noted in there, except they will say 78% F pipe C, basically with a minimum slenderness ratio of 33. If you get more than that, then it's that. So people sometimes look at us like, oh, your stuff has reduced loads. And it's like, no, that's what it is. I mean, when you calculate it, Now, when you go to, but UL, and again, this is a little unclear. It's not really documented, but if you go to 2x6 and that same 115-inch, the slenderness ratio is 21. But a 2x6 at that point is controlled by crushing of the plate. So you might see in a design listing where it says, 73% reduction, 73% allowable of parallel to grain, but that will equate out to 100% perpendicular to grain. So it's what I know it's very confusing, but it's one of those things that people don't know. So that's why if you look at an assembly and it doesn't say load restricted, because it will say load restricted, you can essentially assume full capacity of the stud. There's two things they'll note, like in an evaluation report: your parallel to grain and your perpendicular to grain. But in the design listings, they give you the worst case one. But they don't say, it's 73%. Like our assembly V337. It's a 2 hour, well, it's got different configurations, but in the heading it says 73% reduction. 73 load restriction, but that 73% equates to 625 psi, allowable, which is crushing of the plate.
Yeah.
So it's a full capacity, but it's reading as a reduced capacity.
So I'm curious, what does a 1 hour test actually mean, and what does that have to achieve? You brought up flame propagation, a hose test, and then the E119 test. Does it have, for 1 hour assembly, does it have to meet the requirements of all three of those?
No.
And with that too, when you're testing at 60 seconds or 60 minutes and 1 second it fails, it still passes.
Yeah. So going back to the E119, and I'll call it the FRT equivalents. Those don't have to go together, right? So if you pass for an E119 1 hour wall, that fire retardant equivalence is not a requirement for that. You just have to pass that test. The fire retardant equivalence is if it has more to do with components that might be used in that stud's sheathing. That's what that means.
Okay.
And so to your question, 60 minutes, 1 second, you actually only have to get to 59 minutes, 31 seconds. Now, there's also an adjustment to that too, because it's a curve, it's a time temperature curve, and it's area under the curve. So if you're running a little bit above the curve, you can take time off. There's like a formula to figure that out. So maybe you only have to get to 59:25 or 59 minutes 25 seconds if you've been running over the curve. And if you run under the curve a little bit, you have to go a little bit longer. But if you stay right on the curve, 59 minutes 31 seconds.
So what does that look like for you and LP? How do you develop these systems and then go test them? Are you kind of doing your own in-house math, going, we've tested assemblies that are pretty close to this, so we know it should hit an hour, so we're going to go test it for an hour, or we know it's going to hit 2, so we're going to test it for 2? What does that look like for you? Well,
so I kind of say in part in my introduction is I've done quite a bit of testing, so I kind of see how things work, and it's right. You just have to pass the test. You just got to meet this standard, right? So you go, okay, I could put these components together and come up with a 1 hour wall. So like we have wall systems, exterior wall systems that that have combustible materials on the outside. Wood siding over OS with our, specialty OS with one of our OSB panels. So it's like that's why a lot of times people can confuse flame propagation with fire endurance. Mass timber, right? Pretty good for fire.
Yeah.
You think of throwing a log on a fire, you have to keep the heat going for that thing to burn. Otherwise it chars and insulates.
Yeah, I think an interesting thing with mass timber that they still need to figure out is how to come back and fix it after a fire, especially CLT panels, right? How do you come back and re-add strength? Glue lamp, there might be some simpler ways of adding depth to it. But.
Well, you over-engineer it. Make it 1.5 inches thicker.
So how was the acceptance criteria developed?
So I think a good example would be like our flame block panel, right? It's a OSB that has a non-combustible coating on it. So that technology is not in the building code, right? This kind of would be deemed a new technology, but the building code doesn't discriminate against new technology. So let's say you have this product, you kind of work with ICCS and they develop, you kind of develop this acceptance criteria. And when you develop that, it's not like just you and ICC put it out, they put it out for comment. So, your competitors will try to, do things, but it allows everybody to weigh in on it, and then you go, and it might be like, okay, if you're going to demonstrate this, you need to run through this weatherization part, do the test, collect the data, get it from an accredited lab, and then you submit it to ICCS, and then in our case, they'll give you an evaluation report. So that's kind of how it works. Or, you'll see certain types of products, even like fire-treated wood, right? They have acceptance criteria that they have to, you don't just say, oh, hey, we passed this test, here you go. It's like, okay, you need to do this, then do the test, then submit it to us. Like weatherization, right? Our products is probably something you're going to want to see it go through some kind of weatherization before you test it to demonstrate, this thing's exposed during construction. It's going to perform as intended.
So I'm really curious. I think the best maybe example I could think of is you have a fire rated floor assembly that you need, let's say 1 hour rating. And you get, I'm guessing it's more or less looks like kind of a detail with explanations on how you build that up from, let's say, just UL or that LP is providing. This is this assembly that we've tested. What is the opportunities to adjust that? So the reason I brought up the floor, let's say that the engineer or the architect say to glue the floor sheathing to the joist for more of a preventing squeaking in the future, right? I think it's a common thing. Like, does that all of a sudden change the assembly to where you can't use it if you, were to add glue?
Okay, great question, because this kind of stuff comes up all the time. So one thing is there's, like a UL design, it can't list everything out in there. So they have the ANSI UL 263. It's a link right on top of every assembly. And that's kind of like the general notes of an assembly. If an assembly says gypsum has to be nailed on, you go into that document, it says, the ANSI document, it says you can use screws instead of nails. You have a gypsum assembly and you need to add a gypsum assembly shows gyp, stud, gyp, but you're adding, because it's sure wall, you're going to put plywood or OSB on there. It doesn't show in the assembly, but again, you go to that document, it says you can add a structural panel to these assemblies. So what's shown is the minimum for the assembly. You can generally add to it. You can't take away. So even if you have like a 1 hour wall and then even though the assembly doesn't show, say it shows like vinyl, the drawing, the architect's showing vinyl or wood, but it's combustible. When you expose it to the furnace, whether it's vinyl, wood, piece of paper, it's still going to protect that assembly for some amount of time before that assembly gets exposed to the fire. So adding wood, or like you're saying, glue, doesn't note it. Is that taking away fire resistance? That's kind of how I tell people to look at that.
So it's a little more common sense. Think through it. If let's say it's the most flammable glue in the world, probably a bad idea, right?
Well, potentially, yeah. Potentially. I mean, it's common sense, but it's like if you're putting wood out, even paper, right?
Yeah.
Paper's going to go up fast, but even if it's a fraction of a second, it's still shielding the thing for some amount of time.
Okay.
And that's kind of, a lot of times people don't want to make decisions. People don't want to use their judgment because they're worried about making sure I have a CYA, so that's something that comes up a lot. It's like, well, your assembly doesn't show, wood siding on it. And I'm like, well, that's not...
It's sacrificial.
It's sacrificial, yeah. Even though it is combustible, yes, it is combustible, it's still protecting the wall for some amount of time. And it's like, well, I need to see it on paper. And it's like, use professional judgment.
So just for context here, I really like to frame things in my head that way. Can you tell me a little about the history of fire engineering? I know NFPA has been around since 1897, so it's been going for a very long time. You talk a little bit like an architect says, we've been doing this for 30 years. How much has that changed over time? And just the history of this in general.
Honestly, I don't know, because I've only been doing this for about 5 years, but I think it's kind of like earthquakes. It's like earthquake, what failed? All right, let's take measures to make sure that doesn't happen again. Parapets, right? Parapets, and it's like, oh God, we got to make sure we anchor this thing down, because the thing's going to whip off. And I'm sure the same thing kind of goes with fire, right? There's that big fire in London, 4 years ago, where basically the fire went up the outside of the building, like came through a window, and it basically traveled up the wall. So, there's a test standard here in the U.S. It's called NFPA 285, which kind of mimics that test. Like if the fire's inside, it jumps out the window, it can't propagate up the wall. So what I have noticed since that fire in England, a lot more jurisdictions are getting a little more particular on NFPA 285.
Interesting. Where do you think the future of fire design is going? What are you seeing? Maybe the code's changing too, or what do you think will be the biggest changes in the coming years?
Well, I can tell you what I'm thinking. I'm not sure where it's going. Obviously, codes get more stringent, but kind of how I look at it is, how can I maybe kill two birds with one stone? And coming up with systems that are perform and also offer an additional benefit.
So obviously, there's the UL test has a specific laboratory that is organized to do this testing officially. Do you guys have an in-house, I assume, lab that you can run? If you come up with an idea, you can test it real quick and see how the assembly works before you bring it to a real formal UL style test?
Well, we don't have a lab ourselves. So there's a handful of, I'll call them labs in the country. There's obviously UL. They have a lab. There's a handful of labs in Texas, and the lab I like to use is in Kelso, Washington, which is close to me. So it's like, okay, if you're going to do, let's just hypothetically say you're going to go through UL, you're going to run your design listing through UL, and your product, that you have to have a product certified by UL. I can't just go test some product and then go to UL and say, give us an assembly. So you have to have your product registered by UL. But before then, I'll go see, okay, what do we got to do to pass this test? And a lot of times it's, I'm trying to figure out how much stud chars, because all these assemblies are stud chars. And from there, you can back calculate out, how much load you could load the wall to. And so you'll do a small scale, the lab gives you the data. That's, LP's data. If you want to move forward and you want to get a design listing, you have, like, UL will witness it, the construction and the testing. So again, the lab in Kelso, Washington, it's just close to me. I like it, and they do a good job. UL will come in while they're building the walls. They watch it, they take measurements. I mean, they build the wall pristine. It's true. Everything's nailed right in the right spot, and then basically run the test, and then UL is there when you're running the test, and then they review the data and we'll give you a design listing. And it's kind of the same thing if you're in their lab. Somebody's basically going through documenting it.
Okay, so I really want to learn about this flame block. So can you tell us a little bit about it? How many minutes can LP flame block decrease flame spread? We'll start there.
Yeah, so kind of like that's a question. What's the time assigned? How much stuff does it have? So it doesn't have an assigned time. So like that FRT equivalence, the 2303.2, the coded side of the panel provides that. So again, you just have to meet that test. It's like when you say 1 hour wall, right? It's not a 70-minute wall. It's a 1 hour wall. So you don't, but it's our panel, we use for fire resistant construction. It's basically an alternative to, fire treated sheathing, and gypsum, kind of our wheelhouse is taking layers off the wall. So a lot of times we can pull one layer of exterior gypsum. We even have, we have some really good assemblies or options, I'll call it, to minimize the amount of gypsum on the wall. Mm-hmm. We have some double-sided shear wall ones that are pretty boss. It's, again, going back to structural engineer showing value, right? Back when I was first came to LP, I'd go to meetings and I would bring up something like that I saw from chapter 7, right? Or, from the code, like, hey, type 3 non-bearing wall only needs 1 hour. Right. So you basically run your framing parallel to that wall. It only has to be 1 hour rated. So like with our systems, it's one sheet on each side of the stud. So if you have a building up against another building with minimal, access, it's like, okay, hey, architect, let's make that a non-bearing wall. This is type 3 construction. Let's make that a non-bearing wall. That way we only have to put one layer of sheathing on the exterior face of that stud wall. So basically they can build the wall, tip it up, instead of having to get lifts out there and start putting gypsum over it. So again, another little thing of value engineers could add. But anyway, going to an architect, I brought that up and they're like looking at me because they think, what's your angle? And I was like, I used to get paid $150 an hour to tell you guys this, and I'm giving it to you for free. Anyway, sorry. I went on a sidetrack there. I wanted to say that for you guys too. I wanted you guys to know that.
No, I think that makes a lot of sense, and another great place to provide value to your clients. I mean, if we can influence a bearing wall to non-bearing wall and help save money and construction costs, I mean, that's a pretty big deal. So
but you got to get the engineer mindset out of your mind for that, because an engineer will go, well, no, that's a bearing wall because it has load. And it's like, yes, you do have to design it for its load, but by definition, it's not a load-bearing wall.
So with the flame block and being a fire-rated OSB sheathing, are there any reductions in our shear values, our assemblies, anything like that as a structural engineer that we need to think about? And maybe even a bigger picture of just any sorts of fire-rated materials.
Well, so with the flame block product, in terms of shear, there's no reduction because the panel's not chemically treated, so it's, it has the coating applied to our APA OSB. So in shear capacity, no, it's no reductions. You do have to look at some of our assemblies. They do have reduced axial capacities. That's kind of, I was talking about, make sure you read through, what it says, 73%, like I was saying with the 2x6 really is a full capacity because it's 100% of the plate, but there are some other ones that are reduced. And that has to do with, studs char, during these things, and, you lose cross-sectional area.
Tell me a little bit, what does the fire-resistant assembly look like often? Is there anything special that we need to do at the joints of the panels?
So great question. Now, a lot of assemblies, like ours, there's gypsum is on the interior face, So gypsum, they put it up and there's joint treatment, so there's a requirement, usually you'll say in the design listing, treat the joints. Now there is you dig into some notes, it's like if you do square edge gypsum, you don't have to treat the joints. So like when you see like the exterior gypsum going up on a building, right, you don't see them taping the joints. It's because it's a square edge. So like with ours, going back to, you got gypsum, stud, there's an insulation requirement. A lot of times people don't think insulation really plays a part, but it can often play a huge part in the assembly. So pay attention to the assemblies. And then if you get to the exterior, like with ours, you'll have the flame block sheathing. We don't require, our systems don't have the joints caulked. And sometimes people think, do I have to caulk them? And it's like, what I tell people is, if we haven't evaluated with caulk, we probably don't want you to use caulk, because fire is can be very, what I've learned is very counterintuitive. Uh-huh. Sometimes, if you have something exposed to heat or fire, right, you give off gas, right? So you probably want that gas to escape somewhere. So if it has a mechanism to go towards the fire side versus being pushed into the interior side. And so you don't gap, and then you gap your panels, the 1/8 inch. And a lot of times people go, well, I got a 1/4 inch gap, and usually when those bigger gaps occur is because they have bundled studs. And then this is where professional judgment comes in, because that's outside the scope of an assembly, because you don't test with a joint. But here's the intuitive thing. It's like, okay, single stud with an 1/8 inch gap versus 2 studs with a 1/4 inch gap. I mean, which one has more fire endurance? What do you think, Zach? So yeah, at these wall assemblies, it's a representation of typical construction, right? You can't go and test every little thing that's going to happen or every little potential configuration.
Yeah. How many flame block assemblies are there that have been tested?
Oh, we're probably pushing 60 something.
Wow. Okay.
Yeah. And what I would say is evaluated. to E119, because that's what a lot of times people say is it tested, and it's like it's evaluated. Because you usually have, we would go to UL and it's like, this is what we want. We want X, Y, Z. They'll do a study and they'll say, okay, you need to test X, and then if you test X, you'll get Y and Z. So that's why I say it's it's evaluated.
Is that a piece of it?
Yeah.
You bring a sample?
Yeah.
Oh, I see.
Yeah, I think our goal, not our goal, but I wouldn't be surprised by next year we'll probably have over 100 different assembly options.
Yeah. That sounds very nice for construction, just to have the options there, like not kind of locked in one case.
Yeah, and it will be, with products other than the flame block.
So, Scott, what typical structural details that us structural engineers are doing do you see as wrong when it comes to fire?
I wouldn't say wrong. I'd say maybe missing something. And that would be the rim condition, the floor-to-wall interface. Interpret different all over the country, but generally that rim is considered floor at the exterior wall. So that interface between the floor and the wall is often, I think, deficient in the fire resistance it needs to have. Because you think about it, it's got to support the load above, it's load bearing, but it also has to resist, the fire coming through. So a lot of times I'll see a single 1 3/4 rim or 1.5 rim or whatever's in there. Well, that by itself doesn't even have 1 hour resistance. So you lose a rim, you lose your ability to support load. Now, potentially, if you're doing I-joist can't take much vertical load. Truss, maybe, your wood could be, you're doing floor trusses and the trusses can carry that axial load. But that's one of these things that's kind of a simple thing, for an engineer to catch and look at. Residential construction, what they typically would do is put a double rim. If we're doing solid sawn floor, you put two bys as your rim, and you have resistance from either side. So one's the sacrificial piece, one's the structural piece. Yeah, and it's kind of the same thing you get on, let's say exterior wall type 3, right? Yeah, you could detail it 4 different ways. You could detail it one way, contractor will push back, but like if you just ring that rim with 5.5 inch thick member, and then you could hanger your floor framing off where you need to, and those aren't the $40 hangers, those are the $4 hangers, or you put 2 1 3/4. It all depends on the required resistance you need, but just looking at, go to chapter 16, kind of look at the table 2, the CLT, figure out, okay, for this much exposure, how much, section do I have left? And is that enough to sustain the gravity loads? I mean, or the American Wood Council, DC Design Criteria 3 has details for that, for that floor-to-wall interface in Type 3. American Plywood Association, D350, has similar floor-to-wall systems, because it's not a UL standard. So people will say, oh, I need the UL assembly for that. I need the UL assembly for that floor-to-wall interface. Well, there's no test standard to test to. So there are no UL assemblies. So that's where professional judgment, or it has to be designed, comes into play.
Yeah. Well, Scott, we'll direct all of our listeners to reach out to you if they have any questions on fire design. And we'll put your information down in the show notes. But thank you so much today for taking the time to talk with Max and I.
All right. Thank you, guys.